Right, hello Year 9. So today we're going to start this thing called organic chemistry. So that's anything to do with carbons really. So in Year 9 we only look at a sort of subcategory of organic chemistry called hydrocarbons. So you need to learn the definition for that. So hydrocarbons are molecules that contain only carbon and hydrogen atoms. So there are lots and lots and lots of molecules that contain carbon and hydrogen, but only a sort of group of them contain carbon and hydrogen and nothing else. And that group is what we're interested in. They're the hydrocarbons. So even within the hydrocarbons, there are different groups. Today we're interested in a group called the alkanes, and they're the simplest ones. So alkanes. Alkanes are hydrocarbons where the molecules are joined together by single bonds. So what I would like you to do is a table like this. There's one on the PowerPoint, and you need to fill in this last column first. So the displayed formula is like a structure or a diagram. So we're starting with one carbon, so we'll do this one together. So you just need to draw one carbon, and you need to add hydrogens until each carbon, in this case the only carbon, has 4 bonds. Hydrogen atoms can only make one bond. So we put 4 bonds on our carbon. Each of those can have a hydrogen on the end. So that is the displayed formula of our first alkane molecule. So it has 1 carbon atom. Its molecular formula is CH4. So 1 carbon atom and 4 hydrogens. And that molecule is a molecule called methane. Methane is the gas that comes out of the gas taps in the lab. So pause here, do the rest of the table. And welcome back. So you should have, for 2 carbons joined together, each carbon with 4 bonds, looks like that. Put a hydrogen on the end of all those empty bonds and you end up with something like that. So this is C2H, oh, I've missed a hydrogen, there we go, 6. And that molecule is called ethane. You're going to need to learn the names of these molecules. The next one down has 3 carbons. So again, we want each of our carbon atoms to have 4 bonds, like that. Put hydrogen on the end of each one. We get something like that. The molecular formula is C3H8, and that molecule is called propane. So propane gas is like camping gas. 5 carbons, your molecule's getting bigger now, but it's the same idea. Make sure each carbon has 4 bonds. A hydrogen on the end of each one gives us C5H12, and that molecule, so once we get past number 4, I didn't ask you to do number 4. 4 carbons is a molecule called butane, but once we get past butane, they go into sort of similar names to what you would know from shapes. So a 5-sided shape is a pentagon. So an alkane with 5 carbon atoms is called pentane. 8 carbons, I won't draw, you get the idea, has 8 carbon atoms and 18 hydrogen atoms and is called octane. So the ones in between you can have a think about. So 6 carbons would be hexane, 7 carbons is heptane, 8 carbons is octane, 9 is nonane, and 10 is decane. But you actually only need to know the first 4: methane, ethane, propane, and butane. Some people like a little acronym to remember that. Monkeys eat peanut butter. Right, so the next thing I asked you to do was a general formula. So a general formula describes the number of atoms of each element in kind of any molecule within a family of molecules. In this case, we're talking about the alkanes. So what we do is, if we say we have n carbon atoms, what kind of algebraic formula could we use to describe the number of hydrogen atoms? So it's more difficult to see with CH4, but we'll come back to that one in a minute. If we have a look at ethane, When N is 2, so the number of carbon atoms is 2, the number of hydrogen atoms is 6. When N is 3 in propane, the number of hydrogen atoms is 8. So it's not just as simple, if we go back to ethane, it's not as simple as it's 3 times as many, because it's not. If we look at propane, we can see 3 times 3 would be 9. It's not 9. So actually the sort of algebraic relationship is 2N plus 2. So if you look at any of these, if we look at methane again, 1 carbon atom, so N equals 1. So 2 times 1 is 2, plus another 2 is 4. If we do it for octane, N is 8, so 8 carbon atoms. So 2 times 8 is 16, plus 2 is 18. So this thing here is called the general formula, and you may very well be asked to do that in an exam. So you would have to be able to say what the general formula is. I'll do the extension on another video or at the end, so you can have a look at that later. So the next thing is draw the structure of and write down the molecular formula for hexane, decane and octane. So hopefully you can do that without too much issue. Hexane, remember, was 6 carbons, so has that molecular formula. Decane was 10, so has 22 hydrogens. Octane we've already done. You can draw the structures yourselves. Okay, so a few things that you need to know about the alkanes. So the main thing is that they don't do very interesting chemical reactions. The only thing we really do with them is burn them, so that makes them really good fuels. So lots of different alkanes are used as fuels, and the energy is extracted from the fuel by burning it. So burning is a combustion reaction. We'll look at that in a minute. Other things that you should know, so as the molecule gets bigger, so as we say, we might go down the group of alkanes. So as it gets bigger, the boiling point will increase. So that's because the molecules are getting heavier. The viscosity increases. So viscosity is like the opposite of runniness. So something very runny has low viscosity. So something like honey is more viscous than water. So as they go down, they get less runny, which means they get more viscous. And they also get more difficult to burn, and that becomes really important when we think about which of the alkanes are the most useful fuels. So these ones here are relatively useful because they're quite easy to burn, but if you had an alkane with like 50 carbon atoms, that would be quite difficult to burn and therefore is not a useful fuel. So you should know about combustion reactions from year 7. We have 2 types of combustion really. We need to know about complete combustion, which is what takes place when there is plenty of oxygen, so as much oxygen as is needed. So in that case, you would have something like, so if we say ethane, if we burn ethane, it's going to react with oxygen and it's going to form carbon dioxide and water. And those 2 products are always formed in complete combustion. We then need to balance that equation. So we need 2 of those, we need 3 of those. That gives us 7 oxygen atoms, which is a little bit annoying because we can't make 7 oxygen atoms out of oxygen molecules. So we therefore need 7 of those, which means we're going to need 4 of those, 6 of those, and 2 of those. So that's a balanced equation. We also have incomplete combustion, which is what happens when the supply of oxygen is limited. So there has to be some. So in incomplete combustion, you have your fuel. It's still reacting with oxygen, but this time there's not enough oxygen for 2 oxygen atoms to bond with each 1 carbon atom. So we're going to make something called carbon monoxide instead. So carbon dioxide has 2 oxygens, carbon monoxide has 1. We're also still going to make water. That's exactly the same. When you balance your equation, you'll see that we have 2 of those, 3 of those. We now have 5 of those, which is equally annoying. So if we say we've got 5 of those, we'll have 4 of those, and 6 of those, and 2 of those. So you can see where the limited oxygen has come from. So in this case, we were reacting 7 oxygen atom molecules with ethane, whereas now we're only using 5 oxygen molecules. But the point is, this happens when you've got lots of oxygen. This happens if the oxygen supply is restricted somehow. This is bad because carbon monoxide is toxic, poisonous, very dangerous, will kill people. Carbon dioxide is not nice because it causes increase in the greenhouse effect and stuff like that leads to global warming, which we'll look at later in the topic, but it's not actually going to kill people unless you have lots and lots and lots of it and no oxygen. Right, so this was the extension task. So you needed to take hexane, which is C6H14, and work out how many different ways you can arrange those 6 carbon atoms and 14 hydrogen atoms. So if we have molecules with the same molecular formula, C6H14, but different structures, they're called structural isomers. So this is hexane, so that's 1 isomer. So we've already got 1. I can't draw a 1 isomer. When you want to make isomers, what you start to do is, so instead of having 6 carbons all in a line, you put 5 carbons in a line, and then the other one, so you still need the 6 carbons, so the other one you need to attach somewhere else. You can't just attach it to the end, even if you draw it pointing upwards or downwards, because that's still 6 carbons in a line. So you might end up with something like this, or something like this. These are actually exactly the same molecule, just one of them's drawn backwards. So they only count as 1 more. So that's another 1. But this one here, so we've got 5 carbons in a row and 1 carbon attached to that middle carbon in the chain. That is different. So that's another isomer. So that's another 1. That's all we can do with 5 in a row and 1 attached. So then we go down to 4 in a row. So if we have 4 in a row, we have 2 other carbons that we need to attach. So if we attach 1 there and another 1 to the same carbon atom like that, that's another isomer. So there's another 1. But we could also put 4 in a row, and then our 2 extra carbons could be added to 2 different carbons. Again, we can't add them to either of the end carbons, just like we couldn't do that here, because then we'll have 5 in a row, but just bent round the corner somehow. So that's not allowed. So this one here though, because those 2 carbons are attached to different carbons, is different to that molecule. So that's another 1. And actually those 5 are all of them. So that's as many as you can have. The other thing that sometimes people do is draw something like this. But actually, if you look at this, you need to look for the longest chain of carbon atoms. Well, actually, I've drawn it wrong, so that's not going to help. Let me just make it bigger. If you look for your longest chain of carbon atoms, you can see that you could draw a chain like that. So all 5 of those carbon atoms are attached to each other, and then you have a 6th one that is attached to the 2nd carbon in that longest chain. So what, 1st carbon, 2nd carbon, and we can find that this molecule is one that we've already drawn. It's this one. So 5 carbons in a row with 1 carbon attached to the 2nd carbon, which was also this one. 5 carbons in a row, 1 carbon attached to the 2nd carbon. We just happen to be counting from the other end. If you flip that molecule over, it would be exactly the same. So that one, and that one are all exactly the same. If you've drawn anything else other than one of these 5 that I've drawn, you've drawn the same thing, just in a slightly different way. So you need to try and figure out which one it's the same as. Oh, you do not need to know this for your GCSE, by the way.